Hi there, FACT attendees. My name is Luke Stark, and I'm an assistant professor in the Faculty of Information and Media Studies at the University of Western Ontario. And I'm here with my colleague Jesse Hoey from the Faculty of Computer Science at the University of Waterloo to present our paper on the ethics of emotion in artificial intelligence systems. Many of you will be really very familiar with plots from science fiction that look at the havoc that artificial beings with emotions can cause. But here in the real world, what many are describing as the age of artificial emotional intelligence appears to be upon us. Companies around the world are increasingly interested in tracking, analyzing, and synthesizing human emotions in AI applications ranging from automotive to health and wellness to automated hiring and many others. And while these systems are increasingly common, interest in and research on their social and ethical impacts has been slow to catch up. A little bit of work from folks like the IEEE on effective computing has been a nice start, but it really doesn't account for the kind of full range of social concerns that these systems produce. And these concerns aren't in normal science fiction. They're grounded in the here and now, in the ways that emotion AI systems are being deployed in classrooms, in offices, and in our smartphones. So one of the big challenges in looking at emotion generally and emotion's role in AI in particular is the wide range of theories of about what emotions are. These theories are many and varied, and the philosopher Jesse Prince has pointed to this wide variety of definitions of emotion as what he calls the problem of parts. You know, we all probably recognize that emotions are complicated and multifaceted, right? They involve physiological, expressive, behavioral, phenomenological, and mental components. And while they're all wrapped up in there, the problem of parts asks us, which of these components are essential to emotions definition and detection in a particular context, and why. A related problem that Prince identifies, the problem of plenty, asks us to consider if how multiple components of emotion are essential to understanding this phenomena, how these various components hang together in practice, right? How do these different facets of emotion interrelate to one another. Emotions have been studied by psychologists, neuroscientists, philosophers, and many other disciplines over the past several hundred years. And there's still an awful lot of debate and discussion about both these problems, which makes the importation of that work into computer science all the more fraught. So here we'll give you a kind of broad overview of three main categories of theory or model of emotion. Treating emotions as either experiences, evaluations, or motivations. If you treat emotions as motivations, you treat them as kind of interior drives that impel people to activity and action. Much of the work in computer science around this motivational model clusters on the idea of basic emotion theory, which was developed in the 1950s and 60s and popularized by the psychologist Paul Ekman, who did experiments around the world, which he claimed proved that emotions were universal across cultures, were expressed in 5 or 6 different particular basic emotions, and could be legibly read and reliably understood both by human decoders and by automated processes. Basic emotion theory underpins much of the way that Silicon Valley thinks about emotions, as witnessed by Facebook's reaction icons, which were developed in 2016 and which were based on Ekman's work. A second, now slightly outdated tradition treats emotions as felt experiences and as kind of subjective physiological responses to stimuli. This is best expressed through the famous James Lange hypothesis of the 1920s, which suggests that the reason we feel fear when being chased by a bear is because of the startle response that got us going in the first place. However, these theories have largely now been subsumed into a third category of emotional model, treating emotions as evaluations. as elements of our broader sense of judgment about the world, and as connected to other forms of mental appraisal. As exemplified by this phrase from the sociologist Arlie Russell Hochschild, that every emotion has a signal function. The idea of emotions as evaluations, situates emotions in part in their social context. We have different emotions and responses to different social behaviors, and those social behaviors can often vary by context. Sociologists have developed ways to predict emotions in social contexts through theories such as affect control theory, and work by folks like my colleague Dr. Hoey are exploring the ways in which that affect control theory can be used to help shape the behavior of AI agents. Not only are there a number of models for understanding what emotions are, but there's also a wide array of empirical data that can be collected to deduce, the emotion categories that people are expressing at any given moment. But remember, because emotions are so complicated and often, have this strong subjective component, this data is always going to be partial, and so there's always going to be a problem with identifying emotions based on proxy data. Proxy data comes in many forms, including physiological data such as heart rate or facial expression, behavioral data like gait or gesture, graphical data like those Facebook reaction icons, semantic data, dictionaries of words like love or angry or sad, and the kind of interrelationships between people in the social graph. So in the paper, we sort of put together these different types of possible data proxies with these different kind of models for emotion into a taxonomy where we try to place various kinds of contemporary emotion recognition and emotion AI technologies. And one thing you'll note from this chart is how much more prevalent and popular the kind of motivational model is in computer emotion analysis and emotion AI. There are some examples of the experiential evaluative model being developed in AI and in computing more broadly, but they're less popular and less prevalent. So, grounded in this taxonomy, our paper explores some of the kind of ways that emotion should be considered in kind of current AI ethics debates, and some of the ways in which the choices of emotional model and emotion proxy data can have social and ethical impacts. It's important to note that Andrew McStay and Pamela Pavlicek have done some great initial work in this space, developing guidelines for ethical use of emotional and artificial intelligence systems. And this project, in many ways, builds on this work by extending and thinking more granularly about the different models of emotion and different proxy data that go into these systems. So one general concern we start with is the opaque normative weight of emotion in most AI systems. Across the theories we've already described of what emotions are, there's a connection between emotion and human judgment, right? Whether emotions are just full-on motivators or they're elements of a broader appraisal. There's a connection between our emotions and our actions. And so if it's not clear to a developer or designer of these systems what that connection is, all sorts of assumptions about human behavior and human motivation or action might get smuggled in inadvertently. An example of this problem are face scanning algorithms that include things like emotion recognition being used for automated hiring purposes. It's not clear, for instance, what model is behind these systems, and also what the kind of normative weight placed on the emotions expressed by people using these systems are. Why are particular emotions scored more highly or not? What makes this data valuable to collect? So designers and developers should think twice before embarking on emotion AI projects. And a necessary, though not sufficient, condition for such projects is a really clear alignment at the outset between the conceptual model of emotion being used, the data, the proxy data being collected, the kind of social and contextual norms, and the aims of the project itself. But more specifically, we have some big concerns about the norms of basic emotion theory, which is this kind of motivation theory that underpins much of the work in emotion AI and in Silicon Valley emotion recognition more broadly. So, as already noted, the kind of basic emotion theory suggests that emotions are motivational, right? They're sort of an intrinsic and inalterable experience, and that if even if we try to lie about our emotions, that a trained analyst or a computer system can determine the truth of those feelings. And while this idea may seem comparatively innocuous in things like advertising decisions, it becomes much more concerning when these systems are deployed in contexts like law enforcement, immigration, and criminal justice. If we believe that the motivational paradigm is true, it suggests the ability to collect all sorts of evidence about a person's interior thoughts and motivations using these systems, and despite whether or not this person wants that information collected or not. There are a number of concerns with this. One is that these systems are not as accurate on some faces as they are on others. So the work of Lauren Rue at the University of Maryland has shown how emotion recognition systems as part of facial recognition tend to misidentify the smiling and happy faces of Black individuals more often than their white counterparts. So, in line with other work on facial recognition and its biases, right, these systems just don't perform as well on Black faces. But worse, there's an increasing consensus in psychology that basic emotion theories underlying scientific claims don't hold up to scrutiny. In a recent meta review, a team of scientists from Northeastern University found very little replicability in a large number of basic emotion theory papers, and really called into question this idea that emotions are universally expressible in the way that basic emotion theory claims. So if there are these discussion debates even in the context of psychology, it seems it seems foolish to believe the much more sensationalist claims made by many facial recognition technology providers that these systems are able to easily determine what individuals are quote unquote really feeling. We also have concerns about emotion as a locus of experiment in social media platforms and AI systems. I've written elsewhere that algorithmic psychometrics, or the kind of ways in which digital platforms draw on the behavioral and psychological sciences to track and manipulate the behavior of their users, is intimately tied up with emotion recognition and emotion tracking. The 2014 Facebook emotional contagion study was a watershed moment for the public's awareness of the ways that Facebook and other social media platforms are constantly running experiments on users. And this work and subsequent work by Nazanin Andalibi and Justin Buss has shown just how much emotions are a sensitive category for most social media users. That the collection of emotional data is understood as creepy, and there's major concerns about the kind of agency and privacy of individuals when this data is collected. And since these systems are supporting the kind of AI developments of simulating emotion, the idea that a smartphone is a vast psychological questionnaire, raises some serious ethical questions about how much data should be collected in support of AI emotion systems, and how much consent is really being gotten from users. A further concern is that users of social media platforms and emotion AI systems will begin to reify and interiorize the models and metrics of emotion they see in these platforms. In other words, right, users will begin to understand their own emotions and express their own emotions based on the example of the platforms they're asked to use every day. So while when this work was, really focused in the laboratory, this was obviously less of a practical concern. But as commercial products like the Amazon Halo wristband, which tracks users' emotions through their tone of voice, become more and more common in consumer products, this becomes a bigger and bigger issue for emotion AI systems. Cultural products like the 2015 Pixar film Inside Out also ask us to think about our own emotions through the lens of basic emotion theory and in a kind of technologized way. One of the problems with this kind of reification is that individuals have to start to preemptively position themselves as fluent and capable in the emotional expressions, behaviors, and gestures that a platform most easily understands, that are most legible to a computer system, right? Able to conform to those schemes, while also having, of course, to perform emotionally in the offline world. And right, this is extra work and extra labor, and it's a special burden on people who are already caregivers and are already forced to engage at length with these systems. And finally, at a broad level, we think that the lack of scientific and normative consensus around emotions may be disqualifying for them in the context of AI research. As I've already mentioned, the problem of parts and the problem of plenty really suggests that it'll be close to impossible to develop a kind of sufficiently capacious model of digital emotions that will work in most cases. And this lack of consensus around emotion and this complexity of this phenomena raises the question of whether, even with all possible safeguards, it's ever ethically appropriate to develop and deploy such systems for public consumption. So, as emotion AI becomes increasingly common and increasingly worked into the technologies that we use every day, we hope this paper provides a springboard for further research on the kind of granular questions we've raised here. What sorts of emotional models are being developed in particular technologies? What proxy data is being collected about human emotion categories? What assumptions are being made through both of those design choices, and what are the kind of normative contexts and business or technical aims motivating this work. We also suggest that further user research and further engagement with global populations is another important source of evidence for the kind of potential adverse impacts of these systems. So we thank you very much for your attention, and we look forward to answering questions during the live Q&A.